To introduce this workshop on the Philosophers of Science, we're going to be discussing Karl Popper and his idea of falsification. So who is Karl Popper? Karl Popper was a philosopher and professor from Vienna, Austria. He is regarded as being one of the greatest science philosophers to have ever lived. Popper was the pioneer for the idea of falsification. Falsification is described as the inherent ability to prove that a statement, hypothesis, or theory is false. Popper developed the concept of falsification because he noted that some theories could never go wrong and could easily accommodate any instances of behavior or change conducive to the theory. He drew on the morale that imposing genuine scientific theories, one makes a definite prediction and rules out a range of observable state of affairs that previous theories failed to do. It's important to recognize that universal theories and laws can never be founded on a single observation. Continuous observations and experiments must support the theory or law. However, it is possible to perform logical deductions, which is using a generalization and then applying it to an individual instance. And from this, you start from a single observation statement, which is your premises, and arrive and falsify the universal laws or theories, which is your conclusion. So for example, if our premises is a swan which is not white was spotted at Bowring Park, then our conclusion is that not all swans are white, because generally we see that the majority of swans are white, but we can falsify the hypothesis of all swans are white by spotting that a swan is in fact black. Falsificationists view hypotheses as tentative descriptions of how to explain universal occurrences. If a hypothesis is to form a part of science, it must be falsifiable. For example, a term that may be falsifiable includes, "It never rains on Wednesday." A hypothesis may be falsifiable if an observation or set of observation statements are inconsistent with it. If you observe that it rained on a Wednesday, you falsify the hypothesis. If the statement is unfalsifiable, for example, it is either raining or not raining, then the world can have any properties and it can behave in any way without conflicting statements. For example, Adler's theory states that human actions are motivated by feelings of inferiority. In any situation, one can pose that the reason they behaved in a certain way is because of the threat they experienced. Therefore, this theory is unfalsifiable because there is no way to disprove it. A good theory is one which makes wide-ranging claims about the world, and thus is consequently falsifiable, yet resists falsification when it is tested. For example, consider these two statements. Mars moves in an ellipsis around the sun. And the second, all planets move in an ellipsis around the sun. The second statement claims more than the first, therefore it is more falsifiable. If the first statement is true, then the second ought to be true, but the converse is not true. So, if Mars moves in an ellipsis around the sun is true, but this does not mean that all planets move in ellipsis around the sun. However, if the statement all planets move in ellipsis around the sun is true, then that means that Mars has to be included in those planets. Therefore, the statement Mars moves in ellipsis around the sun is also true. The order of science is to pose falsifiable hypotheses and then attempt to falsify them. And this is, of course, from a falsificationist perspective. The only way science can progress is through trial and error. Falsification allows for important, groundbreaking discoveries and achievements, which ultimately leads to scientific growth. Theories based on falsification have appeasing consequences because it forces them to become clear and precise. For example, Fortune tellers can make claims so vague that they can always be compatible with whatever happens in the future. This claim allows the outcome to always be accepted, regardless of what the fortune teller may have said. Therefore, it is not a strong falsifiable example. Consider the second. Planets move in ellipses around the sun is a more precise statement than planets move in closed loops around the sun. The latter statement is more open-ended. Thus, any shape that is circular in nature can satisfy the statement. The first statement, which was planets move in ellipses around the sun, is more falsifiable because it is geared to be more specific regarding the planetary motion.
Our next section is going to be on falsificationism and progress. Science begins with problems. Scientists, in an attempt to solve these problems, create falsifiable hypotheses. The conjectured hypotheses are then criticized and tested. Some will be quickly eliminated, while others may prove more successful. These then must be subject to even more stringent criticism and testing. Once a hypothesis has been proved to be correct, then all testing is complete and the process stops. Do you believe that this is the case? If you said that once a hypothesis has been proven to be true, that all testing is complete, unfortunately, you're wrong. When a hypothesis that has successfully withstood a wide range of rigorous tests is deemed to be true, falsificationists don't stop there. They continue to test the hypothesis until eventually it's falsified, and this means that a new problem has emerged. Scientists must then become creative and create a new hypothesis, which is then followed by more criticism and testing. As you can see, this process can continue indefinitely. For this reasons, theories can never be said to be completely true, but it can be said that it has withstood rigorous testing. Hopefully, the current theory that is accepted is superior to its predecessors in the sense that it is able to stand more tests that had falsified the predecessors. We're now going to give you guys an example of the process and the progress of falsificationism. So we're going to start with the observation that bats can fly at night while avoiding obstacles. Now, scientists had a problem with this observation. And the problem was, how do they fly so efficiently at night when they have very small and weak eyes? Obviously, this falsifies the plausible theory that animals, like humans, see with their eyes at night. A scientist could start creating hypotheses by suggesting that even though a bat has weak eyes, they can still see efficiently at night by some way that we don't quite understand yet. This can be tested by releasing bats into a dark room and by having some measurement of how well they avoid obstacles, and then release them with blindfolds on. Prior to the experimenter must make a deduction that bats are able to fly avoiding obstacles by using their eyes, and that they cannot do so without the use of their eyes. From these two premises, the experimenter can derive deductively that the sample of bats will not be able to avoid the obstacles in the test lab efficiently. Once this experiment is performed, however, it is found that bats avoid collisions just as efficiently as before. This means that the hypothesis has been falsified. Now that the initial hypothesis has been falsified, the falsificationist has to be creative and come up with new hypotheses. They may suggest that the bat's ears are involved in its ability to avoid obstacles. To test this hypothesis, they can release the bats again, but this time plug their ears. This time, it has been found that the bat's ability to avoid obstacles has been hindered. Therefore, their hypothesis has been supported. The falsificationist must now try to make the hypothesis more precise so that the process continues. This also makes the hypothesis more readily falsifiable. They may suggest that the bat hears echoes of its own squeaks rebounding off solid objects. To test this theory, they gag the bats before releasing, and again the bats cannot avoid objects. The falsificationist now appears to be reaching a tentative solution to the problem. although it has not been proven by experiment how bats avoid collisions while flying. There could have been numerous factors that may develop to prove the hypothesis wrong. For example, the bat detects echoes not with its ears but with sensitive regions close to the ears. The next topic we'll be discussing is sophisticated falsificationism, the relative rather than absolute degree of falsifiability. A hypothesis should be falsifiable. The more falsifiable, the better, and yet should not be falsified. This means that we want to offer opportunities to progress science in finding more specific theories and reasons for why things happen. However, we don't want our current theories to be proven untrue. More sophisticated falsificationists realize that these conditions alone are not sufficient. A hypothesis should be more falsifiable than the one for which it is offered as a replacement. Instead of asking of a theory, is it falsifiable? How falsifiable is it? And has it been falsified? It becomes more appropriate to ask, is this newly proposed theory a viable replacement for the one it challenges? For example, why would we want to take a new theory that provides less opportunity for growth and specificity than an old one? A new theory is acceptable as worthy of the consideration of scientists if it is more falsifiable than its rival, and especially if it predicts a new phenomenon not touched upon by its rival. As we continue upon our topic of increasing falsifiability, we need to touch on the idea of ad hoc modifications. A modification in a theory, such as the addition of an extra postulate or a change in some existing postulate that has no testable consequences that were not already testable consequences of the unmodified theory, will be called ad hoc modifications. Falsificationists do not like these ad hoc modifications because they're less falsifiable than the original version. As we discussed before, this means that less progress can be made with hypothesis. We're going to talk about an example of how ad hoc modifications are formed. We're going to discuss the theory that all bread nourishes. In saying that, we understand that humans grow wheat, then they convert it to bread and is eaten to nourish our bodies. This apparently did not occur in a fake French village where wheat was grown in a normal way. It was converted into bread the same way as always, but when some people ate this bread, many died. This theory that all bread nourishes has then been falsified. The theory can then be modified to avoid this falsification by adjusting it to read, all bread with the exception of that particular batch of bread produced in the French village in question nourishes. This is an example of an ad hoc modification. As we said previously, falsificationists don't like ad hoc modifications. There's many ways to avoid such modifications. For example, we can find a more original way to accept modifications. We could change the claim that all bread nourishes except bread made from wheat contaminated by a particular kind of fungus. This modified theory is not ad hoc because it leads to new tests and possibly more discoveries and hypotheses.